I do have one more equation, or actually two more examples we're going to look at here, talking about when carbon is burned in a limited supply of oxygen, we have carbon monoxide being produced. There's actually two steps here. Carbon will form carbon dioxide first, and then it will be reduced to give carbon monoxide. But we can't look at those two reactions occur simultaneously, so we can't just directly measure the enthalpy of formation when CO, the formation of CO from C and O2. But we do know the enthalpy of formation of carbon dioxide, and we know the enthalpy of combustion of carbon monoxide, shown below. We have C plus O2 gives CO2. That has a delta H formation, an enthalpy of formation of negative 393.5. CO plus a half O2 yields CO2. That has an enthalpy of combustion of negative 283.0. What we can do is we can actually form that equation using these two equations by manipulating the order of them. So we want everything on the left of this equation to match everything on the left of the two equations we know values for. We want everything on the right to match these two equations as well. So how we can do that is we can reverse the one equation, because we want, remember, the bottom here is what we showed on the first page, the C plus 1/2 O2 gives CO. There was a C on the left of the first equation. There was a CO on the left of the second equation. However, in my final answer, I want CO to be on the right. So what they did is they reversed that combustion equation. Instead of making it CO plus a half O2 yields CO2, they made it CO2 yields CO plus a half O2. And when they reversed the equation, they actually ended up reversing the sign, going from negative 283 to positive 283. Now when we put these two equations together, in a sense when we add them, you're going to see that now that there's a CO2 on the right and a CO2 on the left, those two are going to cross out. There's a full O2 on the left and then a half O2 on the right side totally. So those are going to combine to make a half, because 1/2 of this will cancel out with 1/2 of this. And we're left with C, a half O2 on the left, and then a CO on the right. That's exactly what we want. We add the two values of delta H together, and we get negative 110.5 kilojoules. And that would be to make 1 mole of CO from that equation. So this is what's going on in that process. We see that we have carbon and oxygen. The delta H, the enthalpy change, is reduced down 110.5 kilojoules. And then we have the two reverse reactions that we looked at. The one is where CO and a half O2 are on the left, which would be this one, but we flipped it around and made CO and 1/2 O2 the products, so then it came back up essentially. So we ended up with that final delta H of negative 110.5 kilojoules at this level here. So that's what it would look like graphically. We do have one last sample problem I want to look at. We want to calculate the enthalpy of formation of pentane, which is C5H12, using the information on the in the appendix. Basically, I provided that sheet in our modules. We have the enthalpies of formation and combustion here, which we can look at. So first of all, we need to find the enthalpy of formation, meaning that I have to build a formation equation to know what delta H I'm even trying to find. So we have C5H12 is what we're trying to form. That would be made from carbon and hydrogen. So we could think of it as C plus H2 gives me C5H12, and that's the delta H I want to know. I can balance this. I have 5 C's, I have 12 H's, so I'll make that 6 H2. So this is my formation equation. I don't know directly what that is, but we can look at enthalpies of formation and enthalpies of combustion in order to figure that out. So when I look at my sheet here, see that pentane has a enthalpy of combustion of negative 35.6. So what does enthalpy of combustion mean? It means when pentane burns in oxygen, it will form carbon dioxide and water. That's our typical combustion formula. So C5H12 plus O2 yields CO2 and water. I have to balance this, so this will have to be a 5. The 12 will make this a 6. And now I have 10 oxygens and 6 oxygens, giving me a total of 16 oxygens, meaning I should put an 8 there. So now I have a balanced combustion equation, and we know the delta H of combustion is negative 35.6. So what I can do is, since I don't know anything about the formation equation for pentane, I can think about what other formations I can find and maybe cancel some things out. So this is what we're trying to find. I don't know that yet. I know formation of any element is 0. We can find the formation of carbon dioxide, and we can find the formation of water. So I have CO2. Carbon dioxide has a formation of let's see, negative 393.5. And water water is negative 241.8. So negative 3, and why I chose the gas over the liquid is this is combustion, so it's happening at high temperatures, likely to form steam rather than liquid water. So water is negative 241.8. Carbon dioxide is negative 393.5. So let me write that before I forget it. I think I already forgot it. I know carbon dioxide was negative 393.5, and I think water was negative 241.8. Just want to verify that. Yes, 241.8. Okay, so those are my delta H formations of those two compounds. So I need to write an equation of formation for both of those. So CO2 to be formed would be C plus O2 gives CO2. And I want 1 mole of CO2. So that actually works out perfectly. So I'm just going to write delta H equals negative 393.5. H2O would be H2 plus O2 gives me H2O. I have too many oxygens on the left to make 1 mole of H2O, so I cut that in half. So it's H2 plus a half O2 gives me H2O. That has a delta H of negative 241.8. This is all in kilojoules per mole. So what I want is this equation up here. So I have to use what I have to sort of form that. And remember, we're trying to match the elements and compounds on the left with the elements and compounds on the right of what we have in our equations down here. So we're looking at this equation, and this equation. So to me, I see the C on the left here looks good. The H2 on the left here looks good. The only thing that seems to be on the wrong side is the C5H12. So I know I'm going to have to flip that equation. So let me actually write all these out on the board here. So I've written out the three equations that we have values for, and then put in this box down here the equation we're interested in forming. So again, we're going to leave the bottom two as they are, but we're going to flip the top one so that we have a delta H of positive 35, 35, and then the C5H12 is going to be on the right. So I'm just going to erase that real quick and flip it around. So that now the C5H12 and O2 are on the right. Then we have the H2O and CO2 on the left with our 5 and 6 there with 8 there. So now everything is correct based on what side things are on. We also need the numbers to match up. So what I can do to get 5C, I can multiply this whole equation by 5, make it 5C plus 5O2, gives me 5CO2. Now I can multiply negative 393.5 by 5. And I can do the same for the H2. I can multiply everything by 6. So this becomes 3. This becomes 6, and now I can multiply that delta H by 6. So let's see if everything cancels out. I see that I have 6H2O on the left and 6H2O on the right. Those go away. I see that I have 8O2 on the right. I have a combination of 5 and 3O2 on the left. Those add up to 8, so those go away. And what I'm left with is 5C, 6H2, 1C5H12. So everything is now matched up perfectly with the formation equation I'm looking for. By the way, the 5CO2s cancel out as well. And what I can do is I can add all those delta H's together. 35, 35.6 plus... So 35, 35.6, and that's positive, plus negative 393.5 times 5, and then plus negative 241.8 times 6. Add those all together, I get 117.3. That's going to be my delta H formation of that equation. Say 117.3. So that's a lot. That's a long process. That's why we're going to practice it a little while so it makes more sense. Sometimes you're given these values straight off the bat. In this case, we had to find all of them off the table and kind of be a little creative. But we're able to manipulate all those equations in order to find my delta H formation of pentane.